I'm Noel Rappin. I work in group on engineering, where we do lots of cool stuff. More on that later. What I want to talk about here is what I started to call, when I first did this, I started to call this the 5 habits of highly effective tests. And actually, that as a presentation goal, that focuses on individual tests. But I also want to focus on what makes testing effective, and what makes your entire test suite effective. By the way, you guys should feel free. There's few enough in here that you should feel free if you have a question or something to just raise your hand up. And we don't need to really stand on ceremony. Blink once if you're in me. Just checking. So, all right, what makes testing effective? If you've been following if you follow DHH and the 37 Singles blog, you know that he made some strong claims about what testing should and shouldn't be a couple of weeks ago. And one of the things he quoted that I actually agree with is this quote from Kent Beck, that he gets paid for code that works, not for tests. Now, Kent Beck is the original author of the XP book, and one of the first person, perhaps not the person who invented test-driven development, but certainly the person who first popularized it. And so when Kent says that he gets paid for code that works, not for tests, obviously that has a certain weight. But what Kent, I think, would say is that one of the things that helps him get to code that works is writing tests. So what I want to get across here is effective tests are what help you sustainably deliver features. And the key word here is sustainably. If you're using if your test suite is effective, then it lowers the cost of change over time in your application. I'm sure many of you have seen those scary cost of change curves that suggest that the cost of making any change to your program gets higher and higher over time. And one of the reasons for that is that your code base becomes more and more entangled over time, and your code base just gets more and more complex. And testing helps you do that. Testing lowers the cost of change curve, or at least doing it well, so that you can, 6 months later, a year later, you still have a fighting chance of delivering features at the same sustainable rate that you started with. But the question is, how do you know that your test suite is effective? It's kind of frustrating to put a lot of time into your testing and not feel that you're getting a benefit out of it. And one of the weird things about testing is that sometimes the benefit is kind of invisible. Sometimes the benefit is somebody else's benefit. Like the benefit is that the QA person spends less time QAing that. Or the benefit is that you actually can do code, you can actually deliver a feature in the time you estimated and not overrun the time you estimated. It's more of a, it's not something that you always can see clearly, because it has this sort of invisible, things just stay easy and don't get harder and harder. One of the best metrics that I know of for the quality of a code base in general is the bugs in a good code base, a code base with good effective test suite, the bugs are shallow, which means that your bugs tend to be easy to find and tend to easily be conceptualized as a test that you forgot to write. Oh, we have a problem when the user's name contains a space. The user's last name contains a space. We didn't anticipate that, but that's a case that I can easily write a test. What you don't see as much of when your tests are being effective is I have a problem that occurs when 4 of my objects interact in some sort of complicated state, because you tend to have less of that sort of complicated interaction in your program in general. If your test suite is effective, then you generally do not spend large amounts of time watching the dots fly across the screen that say your test suite is running. And I say this working at a company where developers spend a fair amount of time watching dots fly across their screen as the test suite is running, but we all acknowledge that that's a problem. If your test suite is effective, it runs pretty quickly, and it's not a bottleneck. And as a result, you're spending relatively little time fixing problems that are only related to the tests and are not related to the underlying logic of the code. But one of the best ways that you can tell that your tests are effective in your test-driven design, or BDD, or behavior-driven design application, is that you wind up with an application that has a relatively simple and clean design. You know, one of the biggest misconceptions about test-driven development and behavior-driven development is that it is primarily about testing the accuracy of your code, and it's not. Test-driven development, behavior-driven development are primarily software development, software design disciplines that help you write better code. And the fact that it also validates a certain percentage of correctness, that's a benefit, that's a side benefit. But the real benefit is you will develop better code and you will tend to develop it faster. Kent Beck says sometimes that correctness is a side benefit of this process. And I think that that's largely true. And I think that one of the things that characterizes this debate when people are having issues with testing is because they think that it's primarily a validation mechanism. It can't be. Developer-written tests are generally a very good mechanism for determining if the code is doing what you, the developer, think it should be doing. But they're generally a really lousy mechanism for determining whether what you, the developer, think is doing is actually the right thing, actually the thing you should be doing, or should be doing. So you need to understand sort of what these things are for and what the process is for. The process is to drive you towards writing better code. And if it's not helping you, then your tests are not being effective in that instance. Now, one thing that I did not say is a mechanism for effective testing, or a way to tell that your testing is effective, is code coverage. Code coverage is a measurement of the amount of code, usually expressed as a percentage, the amount of your application code that is actually touched when your test suite runs. And while a good test-driven process will normally push you towards very high test coverage, very high test coverage in and of itself does not say anything about the effectiveness of your tests. It is not a goal to be sought after for its own sake. If you happen to wind up with test coverage, that's great, but it's not something, hitting 100% coverage just to hit 100% coverage is a good way to wind up with tests that are hard to maintain because you're writing tests for weirder and weirder cases that the tests may not actually be amenable to test-driven testing. So this is a software design process. Low coverage, of course, is often a sign that you are having a problem. If your tests are not covering everything in your application, then that is a problem. And that usually means, and if you're starting to do a TDD process, that usually means that you're not doing it, that you're not really doing a TDD test-driven process. So that gets to some things that you can look for to see that your test suite as a whole isn't really effective. And things to look out for that are signs signs that you are not doing that you're not necessarily doing things right is, first of all, you have a lot of test fragility. The tests are breaking. This is really demoralizing. You've written the tests in a way, and we'll talk about some of the mechanisms by which this happens, but you write the test and you write some code and it breaks 15 tests across the application in some other place. It's very much a slowdown, and it's very demoralizing to a team especially a team that's trying to pick up test-driven development. It's often a sign that your code is too tightly coupled, or a sign that you're testing the wrong thing. Another problem is you have a lot of slowdowns. Your development gets bogged down because of the tests. Not just the tests are fragile, but the tests are slow, or the test runner is screwed up, or things like that. That's obviously a sign that things are not working for you. But the most important indicator that your tests are not effective is that you have still, even though you have the test, you have no confidence in your ability to change your code. One of the points of doing test-driven development is that it gives you confidence to make small or large changes in your code and have some confidence that you can find all the places that code, and come out on the other side and that code will still work. There used to be sort of a weird saying that the most expensive thing in the world is like the second best military, because you still have to pour a ton of money in it, and you can't do anything with it because it's the second best, right? There's sort of a similar, there's an analogy, a weird analogy to that, where your test suite can get into this valley, this uncanny valley place, where your test coverage is such that you need to spend a lot of time and effort maintaining the tests because you still want them to be there, but you don't get the benefit of the tests when you go to make major changes in your program. You still don't feel like you can make major changes in your program without a lot of pain. And that is a state where you really want to avoid getting into that valley. And again, we'll talk a little bit about how you can avoid that. So I want to say a couple words here about why TDD works. What makes this a process by which you write better code, and not just a process by which you validate your code. My colleague Michael Feathers says sometimes that the only thing that's important about this is that it is a mechanism for you to think about what your code needs to do because you're expressing your code's requirements, and you're expressing your code's requirements in code. And that thought process in and of itself improves the quality of the coding. And I think that there is some truth to that, but I do not think it's the entire truth. I think there's more to actually executing tests. There's more reasons why this works than just that it gives you an opportunity to think about what you're doing. I think that what happens is that your test suite, because you need to expose all the parts of your program to tests, your tests act as kind of a universal client. Every part of your code base needs to be available to the tests. And that tends to sort of give your program a lot of surface area, to make kind of a biological metaphor. Or a geometric metaphor. Your tests have a lot of surface area, and your code has a lot of surface area, and there are very little parts of your code that are not near the surface. That's because everything needs to be available for testing, but it also happens that that is also very much the same features that just maintainable code in general has. Code that is simple, that does not have complicated interactions with each other, that does not have a lot of state, that does not have a lot of side effects. All of those things sort of come out when you need to expose your code to your test suite, and they are also the things that make your code easier to think about, easier to change, and easier to maintain. And the other great thing about test-driven development is you get really rapid feedback about the actual state of your code at any given time. Normally, if you're really doing the test-driven stuff well, you're very rarely going more than 5-10 minutes without going back and forth between test and code, test and code, and test and code. And this allows your code, your code never gets too far ahead of what you're trying to do. It fights your natural tendency. As developers, we have this natural tendency to add complexity to things, to think about all of the ways that something might need to be done in the future. Well, the original XP group had a saying for that, which was YAGNI. Who knows what YAGNI stands for? You aren't going to need it. You ain't going to need it. Right? And TDD, because of this rapid feedback and this rapid going back and forth, gives you a structure to fight your natural tendency to overcomplicate things, or at least my natural tendency to overcomplicate things. And it allows things to progress more organically in tiny steps. And one of the things that makes this process work is being comfortable with saying, I know this code isn't perfect, I know this code may not be final, but it passes my test, and that's enough for now. And then, what test can I write to break this? If you've ever, it's a style of pair programming that I sort of associate with the people who I've met that work at ThoughtWorks. They pair program in sort of a ping-pong style. One person writes a test, the other person tries to write the dumbest code that they can write that will pass the test. Then they refactor a little bit, and then the test person tries to write a test that will break that person's code, and so on and so forth. You're continually trying to write a test that breaks what you have so far, a test that fails, right? and then on the other side, trying to write the dumbest thing that you can do to make that pass, because there's a value in building up your program dumbest thing to dumbest thing, because then you get to the end, and if you continue to refactor your code every time your tests pass, you find that by going from dumbest thing to dumbest thing, at the end you wind up with something that's pretty smart, and is often a lot simpler than you thought it needed to be. And in this case, simple is a proxy for easier to continue to maintain or change over time. Testing is also a little bit of a canary in a coal mine as to the quality of your code. This is especially true, you guys were talking about mock objects right at the end, this is especially true of mock object testing. It is often the case that if your tests get hard to write, it is a sign not that your tests are a problem, it's a sign that your code is a problem. If your tests are becoming hard to write, that often means that you need to set up a lot of state to get yourself in a place to write a certain test. Or you have a lot of dependencies. You're building dependencies. And that is often a sign that your code can be simplified. It's often a sign that you're missing an abstraction in your code. It's often a sign that you have two things that are more tightly coupled than they need to be. One of the ways that you can tell this, one of the first ways that you can tell this, is that your tests get harder and harder to write. And because of that, I think that making code more testable is a legitimate engineering goal. You'll sometimes hear people say, oh, we don't want to create a new class just so we can test it better, right? And kind of a sneer. Has anybody ever heard that from somebody? Am I the only person? Yeah. I think that making your code more testable is a legitimate testing goal, a legitimate architecture goal of your design, along with making it more performance, making it perform better, making the abstractions better. I mean, a lot of these things intertwine, right? A lot of times making something more testable will make you a better design. But I think putting abstractions in only because it makes it more testable and doesn't hurt anything else, or maybe it hurts something else a little bit, like it's a legitimate thing to take into account when you're thinking about trade-offs of a design. And that's the difference between test-driven development and just doing tests first. The difference is when there is a conflict between the tests and the code, who do you trust? Something's wrong, the tests are hard to write, there's a problem, who is the source of truth in your application? If you're doing test-first coding, then you're implicitly sort of saying that the code is the source of truth. And if there's a problem between the test and the code, I need to change the code. If you are really doing test-driven development, then if there's a problem between the tests and the code, you assume that the tests are right and that the code is what needs to change. If the tests become hard to write, then you assume that that is not a problem with the test, that is indicative of a problem with the code. And that's a little counterintuitive because we tend to want to think of the code as the thing we are building and the tests as this sort of appendix, right? But if you're really doing test-driven design, then not only is more testing a legitimate engineering goal, but the quality of the test suite and the test suite itself is a legitimate part of your work product and deserves to be treated as such. Another thing to keep in mind here. Okay, whoa, back up. Okay, I want to talk here. I started a little late. We're running a little late. I'll get through as much of this as I can. I want to talk about how this plays out at the level of an individual test, right? Because this is where the rubber meets the road, and this is building up an effective test suite is about building up one effective test at a time. The important thing to keep in mind, tests are code, but they're also code that does not itself have tests. Brian Kernighan is credited with the observation that since debugging is more complicated than coding, that if you code something that is as complicated as you know how to make it, you are by definition not competent to debug it. And that is also true of tests. If you write your tests as complicated as you know how to write code, and there's a problem, you are not competent to fix your tests. And the absolute worst thing you can have in a test-driven system is an actual bug in your tests. You will never find it. And for never mean, like, you'll be up all night trying to find it. Your tests need to be simple and clean so that you can tell more or less on inspection that they're doing what they're saying they're doing. Because you can't test your tests. because then you're in an Escher painting or you're in the movie Inception, and that is madness. Another thing to keep in mind, tests have two lives. There's two distinct points where a test needs to be effective. It needs to be effective, first of all, when you are creating the feature in the TDD structure. I write a failing test, I make it pass, I refactor, I write the next test. You guys did do the red, green refactor stuff, it is obvious. Okay, that's the first, and it is a very important piece of a test lifecycle, that it helps you move your program forward by exposing something that your program is not doing. That's what failure means, right? You're exposing something that your program is not doing, whether it's a feature you haven't written yet or a bug. That's what a red test is. But once the test is green, the test continues to live on until the heat death of the universe. And you need to be aware of that as well. All of your tests have some cost. Some of your tests have value. Cost in this case is the time it's going to take to run, because it is a permanent part of your test suite, and it will run every time you run your test suite. And the cost that it takes to understand. Somebody new to your project is going to need to understand what this test does. You, in 6 months, when you have forgotten completely about what you did today, are going to need to understand what this test did, what this test does. I have a cheesy acronym for what an effective test does. This is the 5 habits. I hope you like the acronym. It took me a long time. SWIFT, simple, well-defined, independent, fast, and truthful. I'm going to try and go through this quickly. A simple test is simple if its purpose in the code base is immediately clear. You should look at a test and not just be able to tell what it's doing, but why it's there. What problem in the code base test was put in to solve. So working against that, you have things like, I don't want to go into this tremendously, the most important stuff for our purposes here, bad naming is a real problem. Be careful about what you name your tests. The name of your test, either the method or the description string in our spec, should expose why it exists. And again, you can be too clever in tests. You can be too clever in code as well, but you can easily be too clever in tests. Testing is not the place to throw out your fancy knowledge of Ruby metaprogramming unless you're using our spec and you're tied to Ruby metaprogramming anyway. This is not the place, your test is not the place to show off how great you are. Okay. You should also be aware that sometimes you need to refactor tests. Sometimes you have common setup that you need to pull out into a method or some module that needs to get shared and give it a semantically meaningful name. And again, sometimes if you can't make the test simple, that means there's a problem with the code, and you need to be open to that possibility. You need to look at that. One of the things about test-driven development, and this is a very good mechanism for displaying what the code actually is, as opposed to what you want it to be. And if the test can't be big, can't be simple, you need to, in an egoless way, accept the possibility that you may have written code that's too complicated. And it's often a problem where the tests are not written via TDD. You come back later to fill tests. You often have a problem that those tests can't be simple. They're hard. Okay, well-defined. A test is well-defined if it gives the same result every time. This is often only a problem if you are working in some specific things where your data changes all the time. The notorious issue is dates and randomness. Dates obviously continue. The current time has this nasty way of continually changing on you every time you make a test run. And that can be a problem. You wind up with tests that, for example, work when the team in Chicago runs them, but fail when the team in Palo Alto runs them. Not that we would know anything about that. Also, randomness is anything random is a problem. And things that you can do to work about this. Mock libraries are really good at this and encapsulate. Basically, what you need to do is encapsulate those parts of your code base, isolate them from the rest of your code base. Not just because, in this case, not just because it makes sense from the point of view of coding, but also because when you put a wrapper around something, that gives you a very handy place to put in a mock function. You have a boundary layer that you can deal with in your tests through a mock object map. A related feature is independent. An independent test does not depend on any external state. This is a really good thing. You do not want tests to depend on external state. You do not want tests to have to depend on being run in a certain order. That is a serious problem. What you want to avoid in this case is global data in your tests. You don't want global data in your tests. RSpec and I think Minitest both have features where you can run your tests in a random order, and I recommend that. Although you will occasionally find a crazy bug you won't be able to track down, it's worth it. If you can't figure out a way to do it, run your tests in a random order. If you're in a Rails context, fixtures behave as global data for the most part, whatever their other benefits. You also, so in the Rails context, we're talking about factories, and we're also talking about making sure you tear down database transactions or anything that might otherwise be persistent across the end of the test. I have come to believe that fast is much more important than I thought it was originally. A test is fast if it's fast. I hope that makes sense. Almost all of the things that make a test slow are things that happen in your code base or in your test and not in the test suite, the test package itself. We're talking about things like creating too many objects. How many objects do you need to create to test a sort? 2, maybe 3 if it's really complicated. I've seen people create 50. That's going to drag you. Remember, heat death of the universe. We're creating 48 extra objects every time this test runs it forever. Touching the database is slow. In Rails, as Rails developers for years and years, we overlooked the idea that unit tests shouldn't touch the database. And we have had our unit tests touch the database. And now, if you have worked on a long-term Rails application, you have a 20-minute or 30-minute or more longer test suite because every single test touches the database. It's a problem, and it is something that how to work through it is too much for me to get through. How to work through it in Rails is more than I could cover in this time thing, but it's definitely something that you want to be aware of. Third-party frameworks. Also, we were talking about that just at the end here. You don't want your test to have to call a Twitter API for many reasons. So you want to really do true unit testing, where you're testing one thing and not a bunch of different things. You don't want to be testing Rails itself in your test base, for example. And I really have come to believe this. If your tests are not, your test suite is not fast, you cannot really do test-driven design. My definition of fast here is, can you go back and forth between running the tests and looking at the code without switching your context mentally? Like, if you have enough time to check Twitter while your tests are running, your tests are too slow and you can't really be doing test-driven development. You're doing something else, you're doing something close, you're probably doing something that's helping you. But you're not getting the full benefit of a test-driven process if you have to stop and think while your tests run. Almost done. No problem. Finally, the T is truthful. A test is truthful if it accurately reflects the underlying code. You want it to fail only when the underlying logic is wrong. You want it to pass only when the underlying logic is correct. This is harder than it might seem. It's often a problem where you're testing a surface or much too specific value. It's often a problem when you're testing view layout, output one way or another. You're testing for a specific text string to be in your output. Then somebody comes along and changes what your output should look like, and your tests fail, even though the underlying logic is still correct. That's the kind of thing you need to look out for. Or you're testing for an incidental feature of your code rather than the essential feature of your code. It's also a problem with mock objects. The problem there is you create a tautology. You say stub x to equal 3, and then you assert that x equals 3. And all you have to prove it is that the mock package works. If you're using mocks, you want to be careful that you're using mocks to test the behavior of your application and not the state of your application at the end. It also helps to really understand what the requirements of your code base are so that you are actually testing the essential thing. 2 more quick things. When you're testing a Boolean in particular, you want to make sure you test both sides. This is a small rule of thumb. Test that something is true in the true case and test that something is false in the false case. It's really easy. If you test only half of a Boolean logic and your program returns true, and you're testing the true case, and all your method does is return true, your test will pass and you'll never notice. You need to test that true things are true. On a Boolean logic case, you want to test that it's true in the true case and false in the false case. That sounded more like word salad. What? That sounded a little bit more like word salad than I wanted it to. I made that clear. Another thing you want to keep in mind is the testing pyramid and a chain of responsibility. The testing pyramid is a concept that your test suite as a whole is made up of a lot of very fast unit tests, perhaps a smaller number of slower integration tests using a tool like Cucumber or RSpec integration tests, and an even smaller number of very slow acceptance tests that might use Cucumber or might use Selenium. It's important when you think about that testing. Selenium is slower than Cucumber, which is slower than RSpec or Minitest. It's important that you test things at the right level. A lot of the ways that people get very slow test suites in Cucumber is they use Cucumber to test things that they should be testing at the Minitest or RSpec level because they're not really testing integration. So you need to think about, like, what is the fastest way that I can test this? Am I legitimately testing the interaction of multiple parts of my system so that I need to run through and touch my database or run through my whole stack? Or am I only testing the behavior of one part of my system so that I can not deal with the rest of this? And the chain of responsibility is what you have on the lowest level. Again, in a Rails context, where you might have one Cucumber test that covers something beginning to end, that might be covered by a chain of things where you have a controller test that's testing one little piece of that, a model test that's testing another little piece of that, a service object thing that's testing another little piece of that, and so on and so forth. So the faster tests create a sort of chain that covers the amount that the slower integration test does. I hope you found this helpful. I'm Noel Rappin. I am at Noel Rappin on Twitter. Feel free to follow me. I like that. Also, railsrx.com is my blog and also the blog of my book, Rails Test Prescriptions, which is about Rails testing and is available wherever fine pragmatic programmer books are sold. Watch that space for future announcements. I also, like I said, work at Group on Engineering where we have a lot of very smart, talented people doing interesting things. And if you want to be a smart, talented person doing interesting things, come up to me and talk to me about it. I hope this was helpful. Don't really think we have time for questions up front here, but I'll stay out in the hall if people want to ask me some questions. Thank you for your time and attention.